Hey, welcome back to another lesson in Practical Electronics and Circuits 101, where I explain the theory behind these concepts with a focus on using this knowledge for practical applications. If you haven't seen the previous two videos, I suggest watching them first, since they provide a foundation for the topics covered in this video. Today we'll be getting more hands-on, as you can see with these breadboards and the multimeter I have here. I'll be showing how to properly use these two things today. Originally, I was planning to also cover resistors and capacitors today, but it turns out I already have enough content for one video, and I'd like to keep these at a reasonable length, so I'll be covering resistors and capacitors in the next video. Alright, so as you can see, I have two breadboards here. This bottom one is for a digital guitar effects pedal that I designed, and it actually is using two breadboards that are attached to each other. And this top breadboard is an LED circuit. It's similar to the one that's in my LED pickguard, which I previously made a video about. But anyway, I just wanted to show these as an example of what a project on a breadboard would look like. So in case you didn't know, a breadboard is primarily meant for prototyping circuits. So you would want to make your circuit complete on the breadboard first before transferring it to a more permanent board such as a PCB or a strip board. Breadboards are also really useful if you're a beginner because it allows you to try things out, and nothing is permanent on a breadboard. You can easily just put things in and take things out like this. But today we're gonna start with something really basic. So instead, we're gonna be looking at this, which is pretty much the most basic circuit you can think of. It's just a resistor and an LED. But this will give me a good chance to explain the layout of how a breadboard is connected. So we have the power rails on the top and the bottom. You can see a blue strip and red strip, and then a blue strip and a red strip down here. So like I said, these are the power rails. Each row is connected to each other. So the top row, all these pins are connected. The red row, all those pins are connected to each other. And the same down here. And you can see on this side, I have two wires connecting the rails together. So this black wire connects the ground rails together, and this red wire connects the power rails together. Now, the layout of the other pins in these middle two sections are, instead of rows, they're connected in columns. So, this column is connected, this column's connected, and so on. And the same down here, these columns are all connected, but these two sections are not connected with each other. They're, disconnected in the middle here. So now let's provide power to the power rails. So here I have alligator clips coming from a power supply, and I've stripped two wires here. These are solid core wires. So this allows me to easily plug in the power supply like this. So ground goes to ground and power goes to power, obviously. Okay, I have the power supply turned off though, so I'll turn it on in a second so we can do some measurements with the multimeter. So now let's talk about the multimeter. This is a pretty standard multimeter I got off Amazon for about 35 bucks. It's good, for the price, but you can get more accurate ones that are a bit more pricey, such as a Fluke. Those are probably the best known and well regarded multimeters, but for the price, this works really well and it's accurate enough. And it also has some extra functions here. But today I'm going to be focusing on the functions that you would find in any multimeter, which is measuring voltage, measuring resistance, continuity, and measuring the current. So let's first go over how to connect the leads. So first of all, the black lead, which is negative or ground, You can see here there's a ground symbol and COM. COM is also another word for ground. So the black lead will always be plugged into the COM. You're never going to move this one. Now the red lead will go in input for most of the functions, pretty much all the functions except for measuring the current. When measuring the current, you'll be plugging the red lead into one of these. But let's first start with measuring voltage and resistance, and then at the end, I will show how to measure the current. All right, so every multimeter will be a little different in the way they operate, but I mean, for the most part, they all have a wheel to turn it on and set the function you want. So here I've set it to measure DC voltage. All right, so let's go ahead and try it out. So the main thing to keep in mind is you want to be careful not to cause any shorts. For example, you wouldn't want to short the leads across the resistor like this. If the circuit was on, right now the power is off. Yeah, so just that's the main thing to keep in mind when measuring the voltage is just don't cause shorts between any of the components. So I'll go ahead and turn it on, and we'll try measuring the leads right here. So the thing about measuring, you need to make sure you get good contact. Like the contact is pretty bad. I'm pushing down harder now, so you can see it's registering as 8.91 volts, which is what we'd expect. You might have an easier time just measuring directly on the components. So you can see this resistor. I'll put a schematic of this little circuit up on the screen to make it clear. But this resistor is connected to the positive power rail, and it comes down here, connects to the anode of the LED, and then the other leg of the LED goes into ground, completing the circuit. And by the way, the anode on the LED is the longer leg, so you would want to connect that to the resistor that's connected to the power rail. So you'll probably have an easier time just measuring the voltage directly on these legs. See, the resistor's leg is connected to positive. The LED leg I'm touching is connected to negative. So we're measuring the power supply voltage right now. Now you could reverse these. It's not gonna harm anything. And you can see it's reversed because now we have a negative voltage, negative 8.85 volts. So just keep that in mind when measuring voltage. You would want the red lead to be at the higher voltage, and then the negative lead will be at the lower voltage to get the correct polarity. Okay, so now let's measure the voltage across this resistor. So we see 6.93. And then let's measure this. The LED has around 1.9 volts across it, which is typical for a red LED. You would expect a forward voltage drop of around 2 volts. And yeah, so these readings make perfect sense. And now let's see what would happen if we turn it to AC voltage. Now all of these voltages are DC, so we wouldn't expect to see anything. You'll see the readings are fluctuating a little bit because, you know, the air has signals and these connections aren't perfect. So yeah, it's picking up stray signals that are very weak voltage. But if you connect it to a circuit, it's having a hard time finding the voltage. But you can see that it settles at 0. Which is what we did expect because this is a DC circuit. But now let's test an AC circuit. So to do this, I'll grab my guitar since it turns out audio is an AC signal. So I'll turn this off. Now before I grab my guitar, I have a cable connected with, you can see it's in a jack. So now I can grab some alligator clips that I have here. I'll connect the alligator clips to the the multimeter. And then connect the other side of the clips to the signal coming from the guitar. So yeah, alligator clips are really useful, so you don't need to hold the probes down. You can just connect them and your hands are free to do other stuff. So let's see what happens when I play something with the guitar. I'll be back in a second. Alright, so let's just play a few chords. You can see there was a lot of activity there while I was playing, and now the activity has stopped. We see 0 volts. So yeah, that's AC voltage. Alright, so now let's disconnect this. And actually, I'm going to keep the alligator clips connected because it is easier. Pushing down on the leads of these can sometimes be hit or miss. Like, you have to push down pretty hard to make sure it's consistently touching. And alligator clips just take that hassle out of the equation. Alright, so now let's do resistance. So I've set it to this symbol, the ohms symbol. Again, your multimeter might be set up kind of differently because you can see there's other symbols here. I can change the function to those by pushing select. But yeah, let's start with resistance. So again, you'll leave the leads in the same position as when you're measuring voltage. And also, it's important to, when you're measuring resistance, make sure the circuit is off. If the circuit is on and you try measuring the resistance, that's going to change what's happening throughout the circuit. So chances are your device will stop working or start doing weird stuff if you try to measure the resistance when it's on. It probably won't damage anything. Like, you would just have to turn the device off and on and it should work again. But either way, it's not good. So again, don't measure resistance on a live circuit. Alright, so let's see what the value of this resistor is. So you can see 0.985K. So the K stands for 1,000. So it's roughly 1 kilo ohms. Which I'll be talking more about resistors in my next video, like how to read the code here, but yeah, this is a 1K resistor and we're getting something really close to 1K. Keep in mind that resistors are not perfect, like it's impossible to manufacture something perfectly, so there's always going to be some variance, but again, I'll talk more about that later in my next video. So yeah, that pretty much is how you measure resistance. Not much more to say. While we're on this function, let's take a look at continuity. So now it's in the continuity function. And basically what continuity is it allows you to see if two points are connected to each other directly. And if they are, you'll get a beep. So if I touch these together, you can probably hear, I can hear it's beeping. It's not very loud though. And if I were to connect it across this resistor, it's not beeping because they're not directly connected to each other. There's something in the way. So yeah, this is useful because sometimes solder joints wear out. Sometimes connections get lost. So all you would do is just touch the 2 points you want to see if they're connected or not, and it'll beep if that trace is still intact. Or if it doesn't beep and it's supposed to be a trace that's intact, and that's how you know something busted or, a joint came apart or something. So that's continuity. Now let's talk about current. So on my multimeter here, there's 3 different functions for current, and these will depend on the amount of current you're expecting. So there's microamps, milliamps, and amps. So if you're measuring something and are expecting it to be in like high current, like, maybe 1 amp or several amps, you'll set it to the amp setting and you'll place your positive lead to this 10 amps. So you can see here there's 2 leads. These are for microamps and milliamps. This is for amps. So if we were to set it to milliamps here or microamps here, we would connect the lead to this one instead. And you can see here there's an indication of the maximum amount of current that can flow through. So if you use the microamps and milliamps, you want to make sure you're measuring a current that's less than 400 milliamps. If not, if you measure something that's more, the fuse is going to blow. Now, these multimeters typically have 2 fuses. There's a low current fuse like this one, and then there's a high current fuse. The maximum this one can handle is 10 amps. So again, if you were to measure something greater than 10 amps, the fuse would pop and you would need to replace it. But fuses are pretty cheap and it's not that difficult to replace. You just open it up. Again, every multimeter will be different. But so that's something to keep in mind when measuring current, is you don't want to go over the ratings. But since this circuit is low current, I'll be using this one. The biggest difference with the way things are connected in the multimeter when measuring voltage compared to current is that when measuring the current, you're letting the current flow through the multimeter into one lead and out the other. Whereas measuring the voltage, nothing is passing through the multimeter. It's just like with voltage, you're just measuring the difference between 2 points, but nothing is actually flowing through the multimeter. As with current, yeah, the signal needs to flow through the multimeter, which means you need to take apart your circuit and place the probes in line. So you can do this at any part of the circuit, but I'll be doing it here at the beginning with the positive lead. So I'm disconnecting the power supply positive lead. I'm connecting it to the multimeter's positive lead. And then now, again, the current will be flowing through the multimeter and it'll be going out the negative lead. So now we have it properly connected. Now I'll switch over to the milliamp settings because I'm only expecting maybe 10 milliamps through this LED. It wouldn't hurt anything if we set it to the amp setting. It just wouldn't be as the significant figures would be less, so we wouldn't get as accurate of a result. But anyway, all right, so let's turn on the circuit. And you can see, yeah, so we're getting 7 milliamps flowing through this little LED circuit. And again, if we were to set it to amp setting, well, it's not gonna work because we have to switch the probes. So you can see if I disconnect the probe here, the circuit shut off because we broke the connection. And I'll put it in this one. Now we'll measure. So yeah, you can see the significant figures is really low, and it's not as accurate. It only is picking up, so 0.005 amps is 5 milliamps. It's close to the actual figure, which was 7 milliamps. But yeah, like I said, you want to put it in the correct one to get the most accurate results. Now, the other really important thing to know after measuring the current is that you should make it good practice to always disconnect the lead and put it back in the voltage lead. Because let's say that Okay, so I'll turn off the power supply. I'll disconnect the multimeter. I'll put it back how it was originally. So now let's say I wanted to measure a voltage somewhere. So set the multimeter to voltage. And now if I were to measure the voltage on this live circuit without putting the lead in the proper place, this would cause a short. Because remember, when it's in the current setting, the current flows through the multimeter. So if I were to put the probes over this resistor, the current would bypass the resistor and instead flow through the multimeter. And in case you didn't know why a short is bad, let's think back to Ohm's law. Voltage equals current times resistance. So if we were to cause a short across this resistor, it would take the resistor out of the equation, which means this circuit would have a resistance of 0. And if we tried plugging in a resistance of 0 into Ohm's law, we would, the voltage would be set at 9 volts. So we would get 9 equals 0 resistance times whatever the current is. Well, if we solve this equation for the current, we end up getting 9 over 0 equals the current. Well, anything over 0 equals infinity, and you can't have infinite current. So you can see how that leads to some bad problems, because it's going to the power supply in that case would try to provide infinite current. In reality, it can't provide infinite current. It's just going to provide as much current as it can possibly provide, which would, the power supply has built-in protections for that, so it would cut off the power if it detected that. But yeah, generally speaking, shorts are bad, and you can destroy components with that. So yeah, very important. When you're done measuring the current, always disconnect the positive lead and put it back into the voltage lead. It's just good practice, so you never have to worry about shorting something out. Alright, so that covers all the main functions of a multimeter. The functions I just went over can be found on any multimeter, even a $10 one from Harbor Freight or wherever. But I'll quickly go over a few other functions this multimeter has. It has a function for capacitance, so you can get a ballpark idea of measuring a capacitor's value. This is useful for figuring out if a capacitor is dead or not. But other than that, it's not really useful because it's not accurate. This next one says Hertz duty. Here you can measure the frequency of something in hertz. That can be useful sometimes, but generally speaking, if you're worrying about frequency, you probably want to get an oscilloscope, but those are quite a bit more expensive, so yeah, I guess it's convenient to have this function. Next is a temperature sensor. So this actually comes with a little adapter that plugs into the leads and a thin little temperature strip thing that it's pretty useful depending on what you're doing. Next is HFE. So this is to measure the gain of a transistor, which actually is pretty useful in a lot of things, such as when you're building guitar effects pedals. I'll talk more about that later in another video where I go more in depth on designing guitar pedals. But yeah, that function can be useful. And that pretty much, that's pretty much all this one has. But again, these other functions aren't really that important compared to the functions that I showed today, which again, every multimeter should have those functions. Alright, so that wraps up today's video. I'll be covering resistors and capacitors in my next video, so consider subscribing to the channel if you haven't already, and hit the bell so you can get notified when new videos come out. Also, if you found today's video to be helpful, then be sure to give it a thumbs up. And if you have any questions, then feel free to drop a comment. As always, thanks for watching, and I'll see you guys in the next one.